Today we will start with the essential amino acid. What mean by essential? Essential means it cannot be synthesized in our body. That can synthesize, not synthesized in our body. That can be taken up through outside in our diet. These are the essential amino acid. First is isoleucine, leucine, lysine, methionine, phenylalanine, threonine, tryptophan, valine, histidine and arginine. These are the essential one. Here is the non-essential. Non-essential means alanine, tyrosine, aspartate, cysteine, glutamine, glutamic acid, glycine, proline, serine and asparagine. So here you will find 10 essential and 10 non-essential. So to remember these, that requires there is HILMATTV. HILLMATTV. That is the shortest form to remember the essential amino acids. Okay. Now I will show you a certain amino acid classification table in which 3 letter is designated for amino acids, and in certain literatures or in NCBI formats you will find a single letter code 2. So the molecular weight, essential, non-essential, non-codon, and these are the glycine, alanine, proline, valine, leucine, isoleucine and methionine. For glycine, GLY, alanine, ALA, then proline, PRO, then likewise methionine, M. These amino acids are designated as single letter code from A to Z. So A to Z, out of them certain amino acid is not there. So you have to remember what are the amino acid that doesn't having a single letter codes or 3 letters codes. Okay. So first we will start with the S. In previous lecture I have said that the 7 are non-polar and amino acid: glycine, alanine, proline, valine, leucine, isoleucine and methionine. And aromatic amino acids you will find three amino acid. One is phenylalanine, tyrosine and tryptophan, because they having a aromatic ring structure or a benzene ring structure. Now polar or uncharged hard groups, that is serine, threonine, cysteine, asparagine and glutamines. Now the positively charged, as I said in previous lecture, that is HAL, HAL or LAH. You can remember this basic amino acid that is positively charged. Then negatively charged amino acid are most having a 2 carboxyl group. So that is called as aspartic acid and glutamic acid. Now last is proteo non-standard amino acid, or coded by the umber or stop codon, that is UAG. Okay, so selenocysteine and pyrrolysines, these 2 are included in this amino acid classification. Now in many examination we are asking as a physical properties of amino acid. So you have to remember that amino acid can undergo acid and base both reactions, in which proton is transferred from carboxyl to amino group to form dipolar is called sweeter ion. Sweeter ions means what? Having the both charges on that. In acid solution, all amino acids are present primarily as a cation or amino acid are base. In basic solution, they are present as a anions, that is amino acids are acids. So this is all about the acids and base. Now sweeter ion, how it forms and what the structure you will find in that. So here is the structure. You will find a form in which carboxyl group is present and carboxyl ion, that is CO2 minus, and amino group present, and ammonium ion, that is NH3 plus. So the structure is uncharged structure and dipolar is there. So the both charges, positive and negative charges through carboxyl groups and positive charge through amino group. So it is called as Jeter ion. Now, how the acid, zwitterion and base. This is the structure. You will find amino acid as a base. Here is NH3 plus and COOH and OH minus H2O is there. Then same thing is similar structures. Here H is removed and lastly you will find similar structure as base anions. So this is all about the amino acid structures and how it is forming and what works in that. Now amino acid can join together into a long chain by forming amide bond, or we can say is that peptide bonds. That NH2 of one amino acid and carboxyl of another amino acid that join together, then CONH, that is amide form. So peptide chain with fewer than 50 amino acid. Protein is reserved for longer chain. Okay, this is all about the how the protein form through amino acids. Now the dipolar nature. There is dipolar nature of amino acid gives the unique properties. What are that properties, or what is the unique properties of amino acid? First is amino acid having high melting point, generally over 200 degrees centigrade, and amino acid are more soluble in water. Amino acid are amphoteric or ampholyte or amphoteric electrolyte, which can react as a acid or base depending on the pH of the solutions. Okay, so this is the one. The dipolar nature of the amino acid gives to the unique structures and isoelectric point. Zwitterion is electrically neutral and exists at specific pH. These particularly pH called isoelectric point. Now the isoelectric point. Zwitterion is electrically neutral and exists at a specific pH. That is a point at which the isoelectric point. Each amino acid has this specific isoelectric point is there. For example, isoelectric point of alanine is at pH 6.02. At zwitterion pH alanine exists. Okay, then we will see the amino acid can join together into forming amide bond, as I said previously. Then dipolar nature, that is also included. Now the last one, or as I said previously, one letter abbreviation for alanine A, arginine R, asparagine N, aspartic D, and cysteine D, C, glutamine Q, then glutamic E, then glycine G, histidine H, isoleucine I, leucine L, lysine K, then methionine M, phenylalanine F, proline P, serine S, threonine D, tryptophan W. Okay, that Z. Z is for glutamine or glutamic acid, GLX. So you have to write your name. Sometimes it is asked in the examination as write down your name as a amino acid structures. So when on the basis of you can write your name. Now the protein structure. There are four types of structures are found in any protein. First is primary, another is secondary, third is tertiary, and fourth is quaternary. Now how the structure looks like. I will show you a primary structure. First is primary structure. Primary structure having a long chain of amino acid joined together and in sequence like this. Here lysine, lysine, glycine, glycine, leucine, valine, alanine and histidine in long chain it is there. There sequence of amino acid join, linear sequence. Okay. In secondary forms, that is pleated sheets, helix or coil. Entire length of amino acid folded in the shape, that is in tertiary structure. Okay. Helix or coil form like ribbon, that is in secondary structure. Or quaternary structure you will find like this. Okay. So this is all about the primary structure, secondary structure, quaternary structure, and now we will see each one in depth. Okay. First is primary structure. As I said, it is long chain of polymer of amino acid joined together with the peptide bond or phosphodiester bond. Secondary structure, you will find ribbon-like structure, and it is folded in alpha or beta pleated sheets too. Okay. Now, tertiary structure like this, quaternary structure like this, and so the copyright from McGraw-Hill, Tata McGraw-Hill Hills, and it is taken from that. The chain polymer of amino acid form a variety of loops or coils and folded sheet into a assortment of bonds and attraction between amino acid within the chains. So C shape and A shape. In between you will find the hydrogen bonds, disulfide bridge between S, and ionic bond between carboxyl and amino, then van der Waals between CH2 and CH2. Like such type of bonds found in the structures, and through which they will form into a various structures. This is the primary structures and beta pleated sheets, alpha helix, secondary structure and quaternary structure, and this is from copyrighted version, that is Pearson's Educations from Tata McGraw-Hill Hills. Also you will find such figures, so write down this. And now we will see the secondary structure, how it is formed and what is their terminus. Alpha terminus means amino acid terminus and carboxyl terminus are there, or a defined pattern of hydrogen bond between the amide groups, and most of the prominent secondary structure are alpha helix and beta pleated sheets, as I said in previous slide. Okay, so this is the secondary structures. Now protein tertiary and quaternary structures, the 3D arrangement of all structural elements are found. Okay, so hydrophilic heads and ionic disulfide bridge, as I said, and what are the bonds are optimized and forced, that is upholding the chain and how it is formed. So these are the 6 cross-linking and ionic interaction, hydrophobic interaction, hydrogen bonding, disulfide bridge, that is found in amino acid joined together to form a protein quaternary and tertiary structures. Now protein quaternary structure of multiple subunit, that is more than larger than 100 kDa, consists of more than one polypeptide, multidimer, oligomer, protomers. There are the geometrically that you will find like this structure A and B. Okay. Now I will show you importance of proteins in next lecture. Thank you.